So property of logarithms, this will be the main one you're going to use to solve equations, but you also have to have all the properties that I gave you for logs. So if x is greater than 0, y is greater than 0, a is greater than 0, and a is not equal to 1, then the following is true. X is equal to y is equivalent to log base a of x equal to log base a of y. So you can go back and forth. So if you need to introduce logs or remove them, you can use this to your advantage. Okay. So we're going to use this basically to cancel exponentials or get rid of logs. Let's use one more thing. I can put it in here in just a moment. I might have given it to you last time. Let me pull it up from the notes just a sec. Four, 3, 4, 4. Here it is. Also, if x is equal to y, then a to the x is equal to a to the y. You know what? Let me phrase this better. Equivalent to a to the x equal to a to the y. So backwards and forwards, you could say, if you have this and the bases match, you can just set these equal to each other. Or if you have this, you can introduce any base underneath and change those things into powers. Does that make sense? And we're going to use both of these ideas to help us solve. It makes more sense to do it this way. I'll show you why. Right, so first example. Yeah, I have exact answers. Some of the questions will have you round, but I'm going to give you the exact solutions. Okay. So if you notice in the homework they're mentioning round this to whatever, then you have to punch it into your calculator. Okay, there we go. Right. So what I'm going to do is introduce a logarithm of my choice, because you can choose whatever you want. See how right here, if you have an equation, you can bring in log A on both sides. So choose whatever. I'm going to choose ln because it's on the calculator and it's my favorite. That's the only reason. Doesn't matter. You could use a regular log. Choose things on your calculator because they're going to make you round. So if it's not on there, don't use it. So step one, introduce a log on both sides. We'll call this 1 and 2. Using 1. So number 1 is allowing me to do this. And I'm choosing ln. So now use all the log properties I gave you last Tuesday. Remember how if you have a log and a power, you can bring it down. Right? Use the power rule. So step 2. Use the power rule to bring down x. That makes sense. Just bring it down. Now solve for x. This is just a number. This is like saying 4x, right? If it was a number, you would divide by that number. Okay. So divide both sides. Step 3. Isolate x like you always have. Divide by this weird number. So x is equal to ln 4 divided by ln 3. I don't know why I started writing weird all of a sudden. Weirder. Okay. So this is your exact answer. If they ask you to round, just punch it into your calculator. Okay. If they don't ask you to round, just plug that in. Okay. Personally, I prefer this, but if the homework doesn't, well, let's do what they said. If you are going to use your calculator, scientific or whatever, I advise you to put parentheses for the top part. If you have an old calculator and you don't have the fraction button, parentheses for the top. ln 4 divide by the bottom. ln 3. That's it. If you have the fraction thing, go ahead and use it. They said round to 4 decimal places in your homework. Pretty much it. So it starts off kind of basic. Last thing, remember, we're trying to match the bases. Here you can't. So you have to use logs. Okay, so that's the difference between the approach on Tuesday versus today. Okay, let's see. Let's do a harder one on the next page. But you guys are cool on this one, right? It's not too bad. All right. Example 2. 4 times 2 to the x minus 3 plus 3 is equal to 83. So yeah, that exponential thing with a 4 on it. This 3 just hanging out there. We're gonna do the same thing we did last time, but you gotta kind of set it up. Do you see what you need to do first? Yeah, what would you do first? Because it looks weird. Yeah, 3's kind of in the way, so let's do that. The first thing I would do is get rid of that strange 3. So now we get 4 times 2 to the x minus 3 equal to 80. All right. Yeah, we should divide by 4. So the idea is isolate the exponential piece and then introduce logs. Don't do it too early. Because if you introduce a log right away, it's not ready, it's not going to work out. Okay, these are gone. So we have 2 to the x minus 3 equal to, what is that? At 20? So first step, subtract 3. Divide by 4. Now we introduce logs because we want to bring the goal is to solve for x. So you have to bring it down in order to solve for it. Okay, that's what we're doing. So we did all those log practicing problems just to solve for this. So right here, I'm going to pick ln just because you're allowed to pick any log. So introduce ln on both sides. Now you can use your log property. So bring down x minus 3. But be careful when you do that you bring it down with the parentheses. Because ln times that entire thing. That makes sense? So use power rule to bring down x minus 3. All right, so slow down for a sec. Up to this point, is it okay? Does it make sense? No? Well, you know which part's bugging you? Not yet. Okay. Yeah, let's go through it one more time. So the goal is to isolate 2x minus this exponential piece. That's the goal. Once you've done so, you want to bring the power down. This x minus 3 because I want to solve for x, but it's stuck at the top. So the first thing we did was subtract 3 on both sides because it's in the way. Once I've done that, and divide it by 4. Right, we've reduced it to 20. Once you're here, we've isolated the exponential part, the 2x to the 2 to the x minus 3. So now introduce ln in order to bring down x minus 3, because that's this right here, what I did from here to here, is a property of logarithms. So I can't use those properties unless I bring in logs. So I brought in the natural log, ln. Okay, that's the only reason I did that. Once you've gotten to this point, you can solve for x. Okay, that's what we did.
You're only able to introduce the natural log whenever it's like when you say whether it's just with an exponential.
Yeah, like you want to, I mean, you can do it anytime you want, but it's only useful when you've isolated this. Because if you do it early, you can't use the properties. You'll just be kind of stuck. But yeah, so once you've done so, you take advantage of all the properties. Here, the power rule is the one we want. So we brought the x minus 3 down, so distribute the ln 2. So I'm going to distribute on the next step here. So x times ln 2, negative 3 times ln 2 equals ln 20. So distribute ln 2. So next step, add the 3 ln 2. It's just a number. It's a weird looking number, but it's just like 0.23 whatever, some decimal. Nobody cares. But don't let the strangeness bother you. I'm adding like 3.7 to the other side. That's it. Okay. So once you've done so, you get ln 20 plus 3 ln 2. I've almost solved for x. I just got to divide by ln 2. That's it. So over here, divide by ln 2. So this is your solution, ln 20 plus 3 ln 2 over ln 2. It's not very pretty, but it's some number. So x is equal to this. Now, if they ask you to round, you're gonna have to punch it into your calculator. That's all you can do.
You really need any parentheses on that top portion, right? It's just straight addition.
Yeah, you want to be careful. Just the whole top part divided by ln 2. If you have an older calculator, be careful. So the top part. Oops. Okay. So this is just a weird way to write 7.3. 3, 2, 2. That's all it is. Now you could have, if you wanted to, you could have divided by ln 2 right here, right, early on, and then just subtracted 3 afterward. That might have been a little easier, especially if they are asking for a number, not the exact solution. But if they want this exact solution, you want to do it this way. If they don't ask for it, then just do whatever you want, just get this number, right? That makes sense. I don't care how you use the algebra, as long as it's correct algebra, you're good. Okay, just no black magic. Okay. So we did two exponential equations, a basic one and a more complex one. Do you want to do another one, or does this make sense? I'm gonna move on to log equations.
It does make more sense, but to be able to do an example.
Yeah, that's fine. Let me get one. Let's see here. Okay. You guys cool on this page? Yeah. This one's a little harder. So there's exponents on both sides. So there's going to be more algebra involved. But there's nothing that's in your way, so you can start by introducing ln right away. You don't have to worry about that part. Okay. So step one. Introduce a log on both sides. Okay, sorry, got distracted. So bring down the power. That'll be step two. Let me write this step. Step two is use the power rule. And bring down your powers. So I'll bring down x minus 4 in front of the ln 3. Bring down the 2x plus 5 in front of the ln 7. So just put them in front. That's it. So now that they're in front, you can solve for x using basic algebra. So the new stuff is using the power rule and introducing logs. Everything after that is stuff you've learned before. But that doesn't mean we remember, right? So gotta practice. It's gotta practice. So what I advise you at this point is just distribute everything out and then get all the x's to one side. Okay. So ln 3 times both of these. So step 3, distribute and expand everything. So you'll get x ln 3 by doing this guy and this one. Distribute the ln 7, you get 2x ln 7 plus 5 ln 7. distribute. Distribute. That makes sense? How we're expanding it? Okay, so at this point, just group everything with an X to one side, everything else other side. Anything with an X, so these two we'll put on the left side. These two we'll leave on the right side. Okay. Use algebra. And isolate X. So right here, you're gonna subtract the 2x ln 7. Subtract the 2x ln 7. So we'll get x ln 3 minus 2x ln 7 minus 4 ln 3 equal to 5 ln 7. If you want to do two steps at once, feel free. No, I'm doing one at a time. Okay. You can add this guy and subtract at the same time if you want. Okay, so now right here, plus 4 ln 3 plus 4 ln 3. You can see how some of these can get tedious. Okay, so I'll stop here for a moment. Are there any questions so far on any of the steps? You can have a negative in front, but you cannot have a negative inside. Okay, so you guys are good? I'm sorry, man, that sounds horrible. Okay. I don't know, take some stretches. Or right like this. It's okay, I'm gonna send them to you anyway. Factor X, and you'll get ln 3 minus 2 ln 7. 5 ln 7 plus 4 ln 3. So we're pretty much done. At this point, just divide this number out and you're good. Finally, divide this out and you're done. And whatever this is your answer. Some decimal number nobody cares about. This would be your exact solution. If they ask you around, then punch into your machine. So depending on how the question's set up, it'll be more algebra intensive. Some might be a couple steps, some might be really shitty like this one. It just depends. So, but if you have to be comfortable with your algebra and your log properties. So when you're doing this, make sure you have your log properties in front of you. If you don't, I don't expect you to have them memorized. So have them at the ready. You guys have any questions? Step 1 through 4. The algebra, I'm sure the algebra is probably the most annoying part. So any of these steps strange? Is it okay? Is it horrid? Is it beautiful?
Like the log group is over the outline that seemed a little easier.
Yeah, like the only new stuff is right here. This is like the new stuff, right? Every step 4 is really basic algebra. Like maybe high school level. This is the college algebra step that we just learned. Introduce ln, bring down the powers, distribute, and then get started. Solving for x.
It's just step one, or two, six, log on both sides, so that. Oh,
Yeah, you can do any log you want, but we do that in order to bring the powers down, because I can't bring them down unless yeah, unless you have logs. So I can't invoke logarithm powers unless I have a logarithm. That makes sense?
Yeah.
Okay. So these are exponential equations. There's many different types with varying difficulty. So the first 3 questions are something like this, okay, on your homework, but they'll ask you to round, so just punch it in. The next 3 or 4 are log equations. I'll move on. You guys cool then? You guys cool with exponential?
Like round, like is there a specific like round packet you want to do, like from like this point, like
They'll tell you like 4 or thousands, etc.
So they do it in itself, but you have like.
Yeah, just read the question first. Make sure it says how many decimal places, and that'll tell you, okay, at the end I gotta approximate. This is where the log equations start. So it's the reverse. Before we had the variable stuck in the power. Now we have the variable stuck inside of a logarithm. So if you see many logs, combine them into one log like we did last week on Tuesday. Then cancel the log. But if you only have one log, then just isolate it and cancel. That's it. So step 1. Isolate the logarithm. So just divide by 5. So ln x is equal to 2. Now the inverse of ln is e. So you'll introduce e to cancel. So step 3. No, 2 rather. Introduce a matching base to cancel the logarithm. So we're going to use this here. A to the log a of x is equal to x. So when you have a base that matches the base of the log, they completely undo each other, leaving you with x because they are inverses of each other. Okay. So right now I have a base e. ln is a special base. So you need to bring e as your base. I need to make them look like this. So use that, I think it was number 2. So e is the base I'm choosing and changing the equation into the powers. That makes sense? So I made these into the powers. So if I had an equation, I chose a base and made them into powers. Is that, you see that?
E is the base, because that's just the. That makes,
Yeah, I chose E because it's the base of ln. So for example, if I had, I don't know, let's say you have like log base 2 equal to 7, right? If I wanted to cancel this log, get the x, I would introduce a 2 as the base on both sides. That would cancel, giving me this weird number. So I'm choosing E because that is the base for ln. But now this will cancel. So the answer is E squared. So the strategy for log equations is get a single log on both sides or one side, then introduce the base. Then you can solve for x. Okay, it has to be in that order. The exponential strategy was isolate exponential and then introduce logs to bring the powers down. Okay, so there's 2 different types. Is that clear? Let me know. I'm trying to go slow because I know this is a weird, it's a tough section.
this one again,
Yeah, this is all log equations. First 3 were exponential type. Okay, so that was the first type of log equation. Let's pick a harder one. All the steps are cool. So we're just going to keep using this idea of as soon as we're ready to. As soon as it's like an isolated log, you're going to do this. Okay. solve log x plus log x minus 15 equal to 2. There's an extra thing you have to worry about when you're solving log equations. You have to test a solution because it's not guaranteed to work. It's guaranteed for exponential, but not logs. You gotta be careful. So remember the domains for logs. Right? You cannot have anything resulting in as a negative inside of a log. Okay. So anyway, step 1. Combine the logs. Once they're combined, you can introduce a base. Right now I have 2 and I can't do it.
Log x minus 15 equals to
Yeah. I use the product rule. Right? So that gives us log x squared minus 15x. So now it's a single log. So cancel your log. Introduce a base to cancel the log. What base should I choose? Right, there's no LNs, so it's not E. What is the base of this log?
13, 10, 26.
Right, the base is like the little subscript. And since it doesn't have one, it's assumed to be 10. Right, like this guy up top on the board is base 2.
It has no both sides, assumed to be 10.
Yeah, this is the common log. So there's no base in front. It's assumed to be base 10. This one is base 2 because there's a little 2. So that's why I chose a base of 2 here. So here I need to introduce a base of 10. To cancel this base 10 log. So these will cancel, leaving you with x squared minus 15x equal to 100.
So, I think, so, the last position.
We gotta solve it. We're solving for x, right? That was the whole goal.
Oh,
So the log's no longer in the way. So solve for x like you would any other time. How do you solve quadratics? No, we just got a factor, remember? Does this factor pretty? I think it does. You agree with the factorization? -20 times 5 is -100. -20 plus 5 is -15. So we're good, right? So solve for x. Do both of these solutions work? Yeah, if you go back to the original, you plug in 20, does this result in a negative?
Yeah.
20 minus 15? So we're good there, right? Log of 20 is fine. So as long as it doesn't result in a negative or a 0, then you're fine. But -5 would be a problem, right? You see, if you plug in -5, you're gonna get -20, or right here, right away, -5 is inside. So I can't use it. But this is not gonna work.
So this portion of
What's up? Not in the domain of logs.
the whole calculation to the-
Yeah, wherever you plug it in, it has to be defined. So this is undefined in both pieces. This one works for both, so we're good. So we only have one solution. Sometimes both work, sometimes neither work. So just plug them in and see what happens. So I'll make a note here. Plug in x equals 20 and x equals -5 and see if they are defined in the original problem. You're going to see that only this one works. -5. X equals -5 of logs. S is an S. Yeah, any questions on 5? Yeah. Here.
You were more, I think that
Yeah, no worries. All right, we're on at 6. The log equations. So ln of 4 minus x plus ln of -3 minus x equals ln 2 minus 6x. So these in the homework, they want the exact solution. So no calculators, no rounding. Okay. So the goal is to cancel all the logs and then solve for x. But you can't do that until you have all the logs combined into one on both sides. So the right side is whatever, it's fine, right? It's kind of ready. These are separate, so combine these two first. So step 1. Combine the logs. So using the product rule, you get 4 minus x times -3 minus x equal to ln of 2 minus 6x. Right here, we did the product rule. Step 2. Choose a base that matches the logs and introduce it to both sides. So the base of ln is e. introduce E on both sides. That will cancel the ln's, leaving you with just a bunch of X stuff. Okay. It'll turn into a regular equation. So I'm going to choose E. This will become the power using property 2. So this cancels the ln's. You're just left with this garbage. Step 3. Solve for X. I'm gonna have to distribute this garbage. Just multiply it out. So this will be what? Negative. Yeah, negative 12. And this guy. Oh, sorry. That'll be 3x plus x squared. Now we have a quadratic. Which part? Oh, okay. Like from here to here?
Yeah.
Oh, so just combine your like terms at this point. So what we're gonna do is move everything to the left-hand side and set it to 0. Right here, I have negative 4 plus 3, so that'll be negative 1. I can't come, there's no other constant, so just leave it like this. 4, you gotta distribute 4 times negative 3, 4 times negative x. Negative x times this gave me those 4 terms. So at this point, subtract 2. I'm going to put it in a descending order. So add 6x. Is that factor pretty? Looks like +7 -2. You guys agree? So x equals -7, x equals 2. I'm out of space.
Seven and two. From the 14?
These,
Yes. From the 14.
yeah, you look at the 14.
Okay. The hardest.
Factors of 14 that add up to 5. 7 times -2 is -14. 7 plus a -2 is 5. Or 7 -2, whatever. Okay. Do those two solutions work? Yeah, I don't think -7 works. Maybe, I don't know. Let's look at the original question. So the shitty part about log equations is when you finish solving for x, you have to check, are they solutions? I don't know. So you got to plug them in and see if you get anything undefined. So if I plug in a 2, 4 - 2 is positive, right? So that's fine. -3 - 2, is that positive? No, it'd be -3 - 2 is -5, right? No,
Positive 5.
-3 - 2.
Negative 6.
Yeah. So this is a negative. So, okay, so just imagine we're plugging into, I can write it on the next page in just a moment, but you got to plug in your solutions.
You wouldn't add, there would get negative. Oh, you put negative 7.
Yeah, -7, +2. Okay, is the solutions. So if you,
That wouldn't give you positive 5.
no, it doesn't.
So
Gives you a
only
negative
get
5.
Factor for the bottom. Wouldn't it be the other way around?
These factors. But when you solve for them, you get these solutions. I don't have space to solve it. You would set each part to 0 and solve for x. But so all you gotta do is plug in the 2 everywhere and see if you get a problem. And if you do, well, then it's not an answer. Then plug in -7. Just plug it in and see what happens. So if you get, no, if you don't get any undefined values, like an error, if you get an error, just stop and say, okay, that's not an answer. So don't include it in the solution set. Because in the homework, you'll plug in 1, 2, or no answers. Depending. If neither work, like let's say If both of these give you problems, and you'd say no solution. If only one works, well, you put just that one. If both work, cool, put both. But no, you gotta check though.
Negatives inside the log.
So yeah, anything that causes negatives inside or zero, you cannot use them. Okay,
So if you use the 7 on the first part, would still be.
Yeah, you'd have a-
Would be next minus parentheses negative 7.
yeah, it'd be double negative. So it would be fine. So let's do the testing on the next page. You guys cool on this page? Plug in x equals -7 and x equals 2 into the original problem. Yeah, solve it. And see what solutions work. In other words, what is the true solution? So x equal 2. Oops, there's a plus here. So you don't have to keep going, because right here you should see right away a negative value. This is another negative, right? As soon as you see one inside, this is not a solution. And you'll see if you try to plug it in. Where is it? ln -5. Okay, -7 will be ln of 4 minus -7 plus ln of -3 minus -7 equals ln 2 minus 6 times -7. All right. So this will be ln 4 plus 7. See, the double negative swaps your sign. Plus ln -3 plus 7. -3 plus 7 is positive, so we're good. Equals to ln of 2. What's 7 times 6? Which will be positive, right? So there's no issue here. We're fine. So x okay. take a short break because these are long. It's 4:30 and come back at 4:50. Put pause and we'll continue. But you guys have any questions on step 4 or before that? The continued log equations.
For the final,
Mhm.
do we have a physical computer, like physical, calculator, or can we use the digital stuff? That's what I've been using, it's just a digital calculator.
You can, what's it called, respondents can give you a digital one, but it's not that great.
Oh, no, I can look on the digital one on my phone.
Not the phone stuff.
Nothing. I don't know how to pull up this one.
All right. So step 1. Combine the logs. So this will be similar to the last example. So this was product rule. So let me write this step, my bad. Yeah, it's base 8. Okay. So change these this equation into the powers or the exponents. Introduce the 8 as your base. So now that the 8's match, you can cancel. leaving you with this. So step 3, just solve for x. So distribute. And then get everything on one side and then factor. And multiply it out, you should get x squared plus 5x plus 3x plus 15. Combining like terms. Should get this. The procedure for solving quadratics is always the same. Set it to 0. Just like always. In this case, you had 15s on both sides, so it canceled. This would be an easier typed factor. So we don't have to do anything fancy, just do GCF. Set each factor to 0 and solve, and you're done with this part at least. Those both work in the original problem. Looks like only 0 does, but we'll test it on the next page. Yeah, it's cool on this page. Any of the steps confusing? Does it make sense? All right, I'm gonna turn the page though. The negative here.
Very last zero. Of X, 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 eight, zero. So I'm using that one. Right.
Uh-huh. So everything made sense up to here,
Yeah, I get all, everything to.
like from here to here. No, just factor out what they have in common. So you're pulling out X from both terms. Do you remember the GCF?
Yes.
Once you factored it out, you set each factor to 0 and solve. Okay. But once you have them, you got to find out if they work. So test X equals -8. So log base 8 of -8 plus 3 plus log 8 of -8 plus 5 equals log 8 of 15. So right away, you should see that this is a negative, right? Doesn't work. So as soon as you see 0 or a negative in the log, then you stop. It's not going to be a solution. All right, 0, and it looks like we should be good. Yeah, no negatives, no zeros, right? We're good. So on the homework, you would only type in 0. On the exam, I'd want to see your work and your steps. Okay.
Out, like that we're checking it.
Say it again.
For the exam students to write it out like that. To check it.
Yeah, just plug it in or I mean, if you want to explain in your own words why one is a solution and the other one is not, that's cool too. But if you just give me 2 answers and not explain, and they're not right, then it will take off a big chunk for not checking. Right.
For testing.
If you don't test them and you give me 2 answers and they're both wrong, then you should have tested.
Right.
Then you got lucky, right? I'm gonna assume that you tested them. If they're both right and you don't check, I'm gonna assume you tested and I'm gonna give you your credit. But if they're not right, then I'm gonna assume you did not check. All right, well, let's use the rest of the time to work on the homework. So work on 4 or 5 and let me know where you get stuck. And I'll help you out. Okay. The last few questions are applying these rules and ideas. So it's similar. Let me show you. Different. So I've just been doing random questions from your homework so far. Try to pick one, a few of each type. The last few are word problems. Let me zoom in. They're not bad, I promise. So they're gonna ask you,
Where is?
here. Here's not today, you just plug in the numbers in. They give you time, they give you interest, and we did this before, you just plug it all in, and you're good. N is how many times you compound. So semi-annually would be twice a year, so you would put 2 for your N or something. Okay, so we did that last year. Okay, so just the formula, you plug in all the numbers. So I define B, N, R, and T.
It's the same rules for like annual and semi-annual, like you don't be like, you want, you like, you can like, forward set.
Yeah, so 10 would be 2, quarterly would be 4. So change the N accordingly. Okay, you say monthly, you put 12. R is the rate, plug in your interest. P is principal, starting with 8,000. Just put in your calculator, that's it, there's nothing else to do. It's a calculator question. The one that's not, it's later. Semi would be twice 2.
Now he's just making things confused. No, we put 30, yeah. On your phone.
I don't think
I believe you.
you won't see that. This guy though. They want to know the interest rate. Find the interest rate, but where is the interest rate? See how it's inside. R. So in order to get the R out, you would have to introduce logs and bring this number down in front, like how we were doing before. So same stuff. So you introduce logs, bring it down, start your algebra, solve for this. So you have everything else. You have N, so 2. That's time 4.5. You have different P's. No, I'm sorry. No, this is a P, this is A.
Two at the bottom. 4.5. On the rate. What is the rate?
Yeah, you're solving for rate. So this right here is A. This is P. So you start with 2,000 and grows to 2,500 in 4.5 years. So that's time. N is 2. So you plug everything in, start your problem. Solve for R. In order to get it, you have to use logs. So just like before, it'll be a question like this. Let's see. Hold up, hold up. Let's go ahead and do this one just because. I don't think I trust you guys. Example 8. You write down the numbers. There's a bunch of words in there. Problem 12 from the homework. E is 2000. A is, I'll switch over in a second, 2500. N is 2. T is 4.5. You got everything, right? Yeah, so this one right here, just put it on paper. Or I set it up, I guess. So let's see, how do we solve for rate? They want to find the rates. That whole paragraph, but essentially it boils down to, you have this information, find this, okay? So plug in A, plug in P. R is what we're looking for. Plug in N. 2 times 4.5, N and T. What's 2 times 4.5? Two? 2 times 4.5? Yeah.
Oh, 9.
Yeah, 9 makes sense. It did? Missed it. All right, so let's isolate this weird thing right here. Divide by 2000 on both sides. So here all I did was plug in the known variables. So these zeros will cancel, leaving me with 25 over 20 equal to this weird thing to the 9 power. What's 25 over 20?
I believe it's 5 over 4.
Yeah, that's 5 over 4. So how would you get to that R? I think there's an easier way instead of logs. Just do a 9th root, both sides. That's it. 9th root. You know how you cancel a 2? You would square root. So it's a 9, so do a 9th root. That makes sense? Okay.
But like 9 on the square root, and then everything inside
Right, ninth root of all this thing.
of all of the vertices is fine.
So both sides, ninth root. But yeah, the entire thing. That makes sense?
9 and 8.
9. So you will need a scientific calculator. The alternate would be raise everything to the 1/9 power. That's the same thing. Right, this or do this or same thing. These are the same. That's supposed to be 2. Remember we said roots are just fractional powers. Right. So depending on what you choose, you'll end up, I'm going to use the 9th power because it's easier on your calculator. These will cancel, leaving you with 1 plus r over 2. To solve for r. Subtract 1 times 2 and you're done. Subtract 1 on both sides. Times 2 on both sides. Let's skip the minor step. Is that cool? What's up? This I didn't show the -1 I just did it. So right here we subtracted 1 on both sides. That's a step I didn't show. Here we're multiplying by 2 on both sides. So now we have r. R is this. So r is equal to 2 times 5/4 to the 1/9 minus 1. Whatever that is. Can give you a formula to find r automatically.
Oh.
If you think about it. Hold on, I'll put it on there just a moment. Let me just find it. solve in general, then all you gotta do is plug in the numbers, and you'll get R every single time. Put this on paper over here. You guys cool on this page? Oh, yeah, no rush. So 5% rate will get this done. They'll get, it will make your money go from 2,000 to 2,500 in this time frame. So now that was the original question, like, what is the rate that'll make this grow? Okay. And I'll give you the formula on the next page. Yeah, so the question said, find the rate that will make the money go from 2,000 to 2,500 in 4.5 years. So basically, that's what they're saying, compounded semi-annual. So I just wrote down the info. They gave us this formula and said, what is the rate? So I got to solve for R, which is inside. The only way I can cancel this power is to use a root or use logarithms. So I chose to use a logarithm because I can just isolate this piece. So plug everything in, divide by 2,000 to get rid of it. You get it by itself right here. Once it's alone, you can do a ninth root or raise to the ninth power to cancel the 9. So I raise both sides to 1/9. Once it's canceled, the R is free. Now you can solve for it. Solving it for it is what we did over here. From here to here.
We first got the
Oh, it was semi-annually on the question, it said like semi-annually, which is, and then it was like 4.5. So I think those in parentheses, and then that 2 times 2, so that.
Okay.
You remember the homework question? Yeah.
Yeah.
Well, I guess on the homework question, it'll say like annually or semi-annually or quarterly.
Yeah, it'll vary.
Give it a number next to that, so then you put those 2 numbers,
Mhm.
basically time those numbers, and that's how we get our.
Yeah, the power will be dependent on the compounding and years. And each question will be different, could be quarterly, semi, whatever. You find R in this equation. Let's say you don't want to do all that work. Use this formula. So this will give you the rate every single time. You just punch the numbers in to your calculator, and you'll get it. Just change to percentage. Okay. That'll save you all the algebra work. You don't have to do the root stuff and all that. Okay. But this is only for this type of interest rate. Okay. If it's exponential, you have no choice but to bring in logs and cancel the E. If it says continuous interest or continuous growth, then you have to use logs. Yeah, so open up the homework and try it out. We'll save the exam 5 review for Tuesday. And I think that'll be the last thing we do. I'll send you stuff for the final later. I think there is one already made, so I'm gonna check. Yeah, if it is, I'll just send you the videos.
Is it still considered for like test 5?
Test 5 we'll do together Tuesday. Final exam review will be something separate.
Okay.
That answer your question?
Yeah.
Yeah.
Sure.
Brother, we're here.
Just get your homework done.
Do you have a brother? There's someone on campus I work to, and y'all was almost like that. But like hurried out the ability. What's our club job? You have to live up. No, like, okay, look. So if you have a family member or somebody, so you know, they all have a twin, right? We did, we all have a twin. And I see somebody who looks exactly like you, you're not.
What happens?
Jitter, is it? Okay, I'm gonna go. I'm
You're gonna switch bodies?
Yeah, so like, okay,
Yeah, maybe.
so my first mom passed away, right?
Get cursed.
The baby dad saw a lady that looked just like her, and sounded exactly like her. Mom, she's already dead. She reincarnated. Big guess. Now they're not supposed to talk to them. Oh, really?